Hey everyone, it's Bradley. Welcome back to my channel, Portly Gentlemen. It is great to have you with me here today. Today's video will be all about my Glycol loop. The internet is actually calling it the PortlyLoop. No, actually, that's just me. Anyways, so it's all about my Glycol loop. It's been running for over a year. I really wanted to make sure that I had all the bugs worked out and it was going to be something that you guys could recreate or reproduce reliably. There isn't a ton of information on how to set up your own DIY loop out there. There's only one, say, homebrewing manufacturer that's even selling components for a Glycol loop that I'm aware of, and that would be Brewtools, of course, does have their own loop, but they use a slightly rigid, flexible, kind of a nylon braided tubing. Nothing wrong with it, but I wanted a more robust solution. So the first part of the video, I'm gonna show you how I plumbed it, how I went through the wall, how I hooked it up to my chiller, what pump I used, why I used that pump will kind of be a quick tutorial. There will be some timestamps in case you're not interested in that. You just wanna learn about solenoids and pumps and stuff like that. So without further ado, let's jump into the video. Research it, mash it, boil it, ferment it, drink it, analyze it, share it. Home brewing is good. So I have chosen to plumb my loop in PVC Schedule 40, 3/4 inch. One of those things, primer and glue is pretty easy to get it on there and make it look clean. I could have used copper. Inside diameter of 1/2 inch copper obviously flows a ton, but copper is kind of fiddly. And I actually determined that this may actually insulate better. And honestly, that's what I'm most concerned with. So this, if you haven't seen it before, this is the anchoring system I'm using. It goes on to this unistrut and it clicks in and locks to place. I'm using zip ties, small ones, to temporarily hold this in place as I build it. With any kind of PVC cement, you want to give it a good quarter turn to make sure that bond is nice and tight. Now we're just going to blow a hole in the wall that I so painfully built and painted. This was a little bit nerve-wracking for me. I'm not sure why, but one of those things I literally, I spent a lot of time getting the walls sturdy and straight and tried to finish them as nice as I could within reason. But yeah, I had that rock wool insulation on the inside of the wall. I will also show you a little cutout here in a moment of what method I use to penetrate the wall and avoid condensation. So here it is, kind of put together. You'll notice that I've actually gone away from the bulk of these shutoffs on the outputs and the return side. I do have the one on the left there, which essentially creates a low pressure zone in the system, which is pretty critical to its proper functioning. Next, it's time for pump selection. Most Glycol loop setups will use a different type of pump. This is an 80-watt variable speed DC fish pump. It's more pump than I need, but a pump running at 50% is better than one that has to run 100% all the time. I did a quick little test at 80 watts, which is full power, and then at 40, I don't even need to run it at 40. I typically run at 25 to 30. I also included a check valve in the system so it stays primed if I ever lose power to work on it. I poked some holes in it. These are on the wrong side of the check valve. You need to do this on the intake side, but that was an easy enough fix. Live and learn. It's still glued up and installed in the reservoir just the same, but that's how I stay primed. Insulation. Now this honestly was the most fun part of the project for me. I especially love this adhesive. It has a real nice smell that kills brain cells if used in a confined space, so definitely ventilate well. And I'm using this foam. These are the pre-cut ones. You can also cut your own. Pre-cut's fairly costly, to be honest, but it does just work a lot nicer. So you want to get this adhesive on both sides, everything. Not too much, but want so it tacks up and sticks together. And just apply it, take your time. And it's super critical. You want to avoid the coolant lines, the conditioned area, if you will, avoiding contact with ambient temperature. That's when you're going to have condensation, and then condensation over a prolonged period of time will lead to mold. My line sets for the cooling loop all kind of have a slope so that condensation goes where I want it if it occurs. I can tell you to date, I've had the system running for over a year, condensation hasn't been a huge issue. And again, it's still temporarily zip tied here and all put together. It does slope down to the bottom left is the lowest point. I have a slit cut, which I don't show in the 90 there. So anything that would happen would at least have a chance to drip out. But again, after over a year of operation, I've not had any issue with it. And just kind of squeeze this stuff and get it to tack up. This is a super critical part if you want to have a good functioning loop that doesn't get moldy and performs as well as possible. And here we are in reverse order showing you this tea The tea, I just did it when it was on it. You can also do that with these. I did stick a zip tie on there to hold it temporarily. I found this technique worked really well. Again, I'm not a professional. It's the first time I've ever used these products, but they do definitely do the job. So just squeeze it, chuck a zip tie on there, and it's going to hold everything together so it tacks up. This stuff tacks up in just a few minutes, and it's a fairly permanent bond. The center sections were one I just kind of cut the centerpiece to length, and it all went together really nice. Obviously, I'm a little OCD. I like to work clean as possible. I just think it makes for a better experience. And I just kind of eyeballed this stuff. None of this was really measured out. You know, more critically, I probably should have. I will say that I did strap all of the tees to my unistrut, and I wouldn't do that in the future. I would just go in the center of the PVC. I thought it would be stronger, but it's actually janky. So these do have the adhesive on them. Don't get this stuff off of Amazon. I'd love to link you an Amazon link, but get it at Home Depot or Lowe's or a local hardware store. I tried some components from Amazon, and they were just, they were substandard and weren't good. So I don't recommend anything from there, to be honest, as far as this insulation. But this has an adhesive tape. So get it and pull them together, and just pull it at an angle as best you can, and then get it to start and squeeze it together. And all this stuff is going to, you know, be butted up and sealed up nicely. Then once you have all of this peeled off, I just kind of, you know, made sure it was fitted, and then I just kind of squinched them all back towards each other. Obviously, I wanted the seams hidden, so I rotated those behind it just because I'm being a little neurotic, but you see it fits properly, and it's really that simple. So like I mentioned, I squinched it back, and then I just dabbed in the cement. You know, this area isn't as critical because, as you'll see, I hide it with this foam tape, and it makes sure that that bond and that joint is really well protected. Again, I really want to avoid ambient temperature mixing with my line set here, my cooling loop. I want that to maintain its integrity. As far as moisture, it's obviously a huge concern of mine. Depending on your climate, it may not. But again, this was super straightforward. Applying this insulation tape, I love this stuff. Cut it to length and just get it pretty tight. It does help hold everything together. Pull the backing off at the same time. And then obviously I tried to do my best to make sure I hid the seams behind it. I just wanted it to look clean. For me, in my little world, although I'm pretty much the only person that sees this outside of YouTube, I did want this to kind of be a standout kind of centerpiece. For me, this was a big deal, getting this loop set up and working. And I really, really took my time. I do think it lends to the system's overall efficiency, the way I put this together. Hopefully this video is helping you guys figure out how you want to set yours up. There isn't much information still on doing one DIY, so this is why I'm doing it. Here's a quick look at how I kind of plumbed up the mechanical space where the chiller is. And guys, it's really straightforward, but I eyeballed a lot of this. Here's the connections. Remember, if this has inspired you, please, you know, like, comment, and subscribe. It really helps me out. It helps the channel. And my goal is, again, to inspire you guys to do something kind of cool and different. All right, so my loop directly behind me. You've seen how I plumbed it, and you've seen the pump I've chosen. I chose that pump because, well, it's always better to have a pump that, you know, you don't want to run it at, say, 100% of its maximum duty, maximum load. My pump, it's capable of 80 watts. I usually run it around 25 or 30, so I don't even need its full power. I went with that kind of decision, or made that choice, because, you know, once you add glycol to water, it becomes more viscous, so it's a lot more difficult to pump, and I just wasn't sure. I'm also using 3/4 inch Schedule 40 PVC pipe. I don't know the inside diameter. Definitely could have gone with 1/2 inch copper, you know, but honestly, I do believe the Schedule 40 insulates better, and that's what I'm after. You'll notice that behind me here, I do not have any ball valves anymore. And originally, I put it together, I had ball valves to be able to isolate each line or each unitank or each fermenter. I decided to just go with a dripless fitting at each point of connection, because I realized I won't really be taking these apart, and the ball valves added just unnecessarily needed complication in length, and my space is somewhat tight. So without those, it's a better setup for me. I do have ball valves on the mechanical side of the brewery that I am able to close it off and fully isolate. My lower pressure side and the top line would be the low pressure or return side. So those ball valves there work for that purpose. I have a ball valve here over my shoulder. This one, like I said in the narration, is to be able to throttle that down. So I'm able to create, again, this top line over my shoulder is the low pressure side. And in a moment, I'm gonna show you kind of how that works and some stuff that just wasn't out there. Again, you know, I do think this is suitable for any kind of a microbrewery, macro brewery, obviously a home brewery, a full commercial scale. They use a lot cooler stuff that I was able to see for the first time in Vegas this past April, which was super awesome. But definitely if you're setting up a microbrewery, you know, this more rigid line I think is a better way to go. I have a lot more flow than other options. So right now, I'm gonna show you how this works. It's really interesting and really cool, and it quite surprised me. So bear with me just a moment. All right, so as we are here, I have one of the dripless fittings. This is a Brewtools fitting. BrewBuilt also carries some nice ones. There's our larger, truth be told, I think both styles of fitting are good. The Brewtools ones are just a little more compact. So I'm gonna go here to this bottom port nearest the F100. There's not a lot of room to see it, but I'm gonna see if I can do it. Again, the system is live and flowing, and so I'm gonna plug in, and I have a tiny bit of flow. That's probably, we'll zoom in here in post, but that is flowing glycol through the system. You don't need a ton of flow. I just have the one unitank on the system, the Mini Uni Plus going. So I'll disconnect from this. This is be my pressure side. And again, they say droopless, that there will be a tiny little drip when this stuff comes out, you know, but they don't leak. Now I'm gonna hook to the return side, and well, probably can hear it, but this is actually now, it's hard to do. It's actually sucking the glycol, and hopefully we can zoom in. You hear that? I'm putting a bunch of air in my system, but that itself does create a venturi and help to kind of pull stuff out through the other side. So it's just one of those interesting little things in the way it worked. I couldn't define this, you know, described anywhere when I was doing research on will this work, how does it work? I just kind of plumbed it the best way I knew, and it turns out I did pretty good because the system works flawlessly. Now the system itself isn't without, it has a few flaws and downsides, and that's just, you know, what's available on the market right now. So I'm utilizing two types of valves to trigger coolant flow through my fermenters. I'm using a Brewtools solenoid valve. Literally think of a garden sprinkler type valve. This is very much that. It's got a solenoid on it, a coil energizes, a little magnet in there. It's not latching, so you know it's constantly powered, so that solenoid is always hot whenever it's calling for cooling. So you know they are liquid cooled, so it's probably never going to overheat, but just keep in mind, since they're not using a latching solenoid, I've not had issue, but it's worth noting if you're looking into this. On the other hand, I'm also using a full flow ball valve, and this ball valve is actually latching. I got these off of Amazon. I will link them below. They are a cheaper option. They do make them also with multiple wires, so you're able to open them and close them at a certain percentage instead of being off or on. And that leads me to one of the biggest kind of problems with glycol jacketed cooling. You will not see this so much in a cooling coil because the coils, they don't hold a lot of liquid, a lot of glycol, so they're less likely to overshoot. If you have a unitank with a jacket, it is possible to overshoot because most temp controllers that I'm aware of currently for this, they're either off or on. So mine will often overshoot by a few degrees, meaning the jacket is charged with cold glycol. Now you can combat this by never running your reservoir cooler than you need to. And again, you shouldn't take it below freezing anyways. You know, if you see ice on the outside, that's ice on the inside of the vessel, that's gonna insulate it and you're gonna lose performance. So I rarely run mine below freezing, to be honest, unless I really need to get something cool and I'm fighting ambient, but I've never had that problem. And my preferred controller right now that's widely available is the Kegland wrapped fermentation controller. This guy, I believe it has the capability to be able to enable some better temp control on the cold side. For whatever reason, they're not doing it. I don't know that it needs to be PID. I think PID may actually be overused in the home brewing space at this point. Not everything has to have a PID on it to work properly, but they are working on a pinch valve that will be able to see that it's getting close to a certain temperature, and it will restrict flow. I would love it if there was some sort of a delay where, put some logic in there where you can program in, hey, we're within 1.5 degrees of the temperature. Let's close the solenoid, close the valve for a matter of like a minute, and just see what the temperature does. If it doesn't move enough in a minute, then open it again for another minute, we'll say, and just see how that goes. Again, overshooting, again, this may not be an issue. I don't know. For me, I have enough heating elements around here, and I'm using premium equipment that heating is just not a problem, whether it's the Brewtools 100 or the BrewBuilt. There's also a video on the BrewBuilt Extra, the new one behind me on my channel. I'll link that below. That's also got a jacket, another affordably priced premium segment unitank fermenter. So those are the two main valves you can use if I haven't lost you there. They both work well. If you have a multi-pump setup, you may not have this issue as bad. If your unitanks are perhaps above the reservoir, they may siphon off into your reservoir and cause it to overflow. But if you have the right level, this may not be an issue. But again, it's one of those things that's not widely discussed, but it is indeed an issue within all of these systems to the best of my knowledge. As far as lines, I have two examples of commercially available lines. I have the BrewBuilt lines and the Brewtools lines. The Brewtools lines are kink-free, that braided nylon in there. They're quite robust. They're really strong. They have a nice PVC, I believe, plastic exterior, which allows them to just keeps everything nice, whereas the BrewBuilt has a just soft insulation like used everywhere else. They both work. The BrewBuilt ones are silicone, nothing wrong with that. I've had zero issue with them in my setup. I recommend either line style. It comes down to preference in my opinion. The Brewtools one may have a slightly snugger fit around the line and the insulation. Again, the more snugly it fits, the more airtight it's going to be, the less condensation. But honestly, the BrewBuilt one also fits extremely well. The Brewtools one just made it a little bit tighter of fit just based on the way it's manufactured. As far as the wall penetration, I was really concerned about condensation in there. I don't want to ruin my walls. My walls aren't super thick. It's only 2x4 wall with sheetrock on either sides of it out here in the brewery. So here is a representation of how I accomplished that. I took one of these, it's like a plastic, I think it's like for a vacuum, and I put the pipe in it and I just expanding foamed it, my charge line. So that's a representation of how I did that. Mine do angle slightly down towards the mechanical side where the Penguin chiller is. And that would ensure that if any condensation gets in here, it's all running to a certain kind of contained area. I've not had an issue with it yet, but if it ever happens, hopefully that little bit of extra thought will help the whole system drain more effectively if I should need to. One of the other things you can see is that I do have my pump sitting on top of the chiller. This pump can be immersed inside of the coolant as well. The glycol solution, there isn't room in my Penguin chiller with the coils. I've tested a lot of chillers and well, only 3. So there's more on the market now. I've used the Blickman and the BrewBuilt, the one with the 4 built-in pumps, as well as the Penguin. The Penguin I have is more powerful than both of those, but it is more energy efficient. It has a better pump in it. It has a better fan. It does move more air. It's really important to keep that in mind. You're looking for a chiller, look for one that is rated at a specific temperature. They might say 3,000 BTUs, but at what temperature? A little bit deceitful. I will say, sadly, the Blickman was absolutely atrocious as far as power consumption and overall longevity. I sent 3 or 4 of them back. I know a lot of other people that have. Blickman took care of it. Maybe they have fixed it since, but like I said, that's one I would not touch with a 10-foot pole. The BrewBuilt, however, treats me well, and I still retain it as a backup, or if I need to do additional testing or run a condenser or something, I use the BrewBuilt for that currently, and it's doing its job just fine. But for my money, the Penguin is probably one of the best on the market as far as raw horsepower goes and efficiency. Hopefully this has given you guys kind of a little bit of fuel to move forward and look at doing something versus one of those multi-pump, multi-hose setups. I personally find them to be tacky, and I think this is a more efficient and more effective setup if you have more than one fermenter. I will say I have yet to implement cable management for the various heaters I'm using and the thermal probes when I'm not using a wireless pill to my wrapped temperature controller, which is by the way just awesome. Yeah, those are really, really good. So again, I'm gonna do that and manage it and get the system a little bit tighter and get it all working a little bit better. I do have provisions here on the outside to be able to hook up for unitanks for testing. Eventually the F100 will move down to the ground and I will get a few more up here on the bench, but that time hasn't come yet. So if you guys have any questions about my setup, components I've used, go ahead and drop it in the comments or shoot me a direct message on Instagram. I'll be more than happy to answer it and walk you through why I've done it and how it's worked out for me so far. So as always, remember, I've been Bradley. Home brewing is good, and I'll see you real soon. This F100 is an absolute beast, and I don't know, it works great. Massive jacket. The BrewBuilt. I like this little thing. Beer is going in this guy soon. Like maybe tomorrow. Yeah, tomorrow. Mini Uni Plus. Again, that kind of cooling performance at that price point with a jacket with that kind of surface area. No one but Brewtools does that. So if you need raw cooling performance, that's what I've found to be their tanks cool the best in my testing. It's unbiased. I mean, want to see that video? I could. It's a lot of work, but I'll make it. Like a lot of work. Time lapses suck. Yeah.